Comparing samples. The concept of the number of standard errors that the sample mean differ from population means applies to both confidence intervals and the significance test. Comparing samples. Number of standard errors. As a sample means differ from sample means differ from population population means differ from this one. This one differ from population means applies to both confidence intervals significance test. The two sample t-test is found by the two sample test. The two sample test is found by weighting the average of the variances. Weighting the average of the variances. X1 from first sample, second sample X2. We have to subtract these two samples X2 from X1, S1 X1 cap, X2 cap. Okay. X2 cap, X1 cap. Then divide by root of S1 square divided by n plus S2 square divided by n square. It means how much we are getting from second sample S2 we have to be square, then this value divided by this n2. After that we have to add this n1. Okay. Then after add with this n1, then we have to S1 square to be divided from this value. After that to be square root, that is reducing value. Then from after x1 x2 subtract to be reducing this value. This is the test, two sample t-test. Here two samples cap sample to be deduct or subtract. Then n1 plus that n1 to be keep it as it is, and this second sample only to be divided by second sample squared and divided by n2, then to be added with this. Then total all of these divided, S1 is divided by S1 divided by this value, S1 square. See here S1 commonly is there. N2, S2 here only N2. After that to be added with the N1, then both divided, S1 divided by this. This is the two test sample two sample t test. Okay. Why here? Actually, only one value, only in numerator. Okay. Here, then both are in denominator. After that, for this s2 square is numerator, this is the n2 is the denominator. So first is this one. After that, with add, then total s1 divided. Okay, this one divided for s1. After that, square root, then total. Okay, where x1 x2 are the means from the sample 1 and 2. Okay, this is the mean s1, x1, sorry, x1 cap and x2 cap are the means from sample 1 and 2. Okay, sample 1 mean, sample 2 mean. S1 S2 the standard deviation. S1 S2 is the standard deviation from sample 1 and 2. S1 S2 is the standard deviation. X1 X2 mean, S1 S2 standard deviation. That is, firstly what we are doing, means of the sample to sample to deduct, and then standard deviation S1 S2 S1 totally, S2 only from N2 only, and N1 N2 the sample size. N1 N2 is the sample size. The degree sample size. How much is sample? The degree of freedom for t values. The degree of freedom for t values approximately 2 less the smaller of the two sample size. The degree of freedom for t values is approximately 2 less the smaller of two sample sizes. A p-value is the just a percentile rank or point in the t distribution. Okay, the degree of freedom, for t values approximately 2 less the smaller of the approximately 2 less the smaller of the two sample size less. Yeah, p-value is just the percentile rank or point in the distribution. P-value is the just percentile rank or point in the t distribution. The null hypothesis for an independent samples, okay, null samples t test is that the difference between the population means is 0, in which case mu1 mu2 mu1 minus mu2 can be dropped. The degree of freedom n1 plus n2 minus 2 fewer than the number of cases with both samples are combined. The degree of freedom n1 plus n2 minus 2 fewer than the number of cases when both samples are combined. Next, between subjects, comparison to sample t test. Between subjects comparison to sample t test. When a different set of users on each product there is variation both between users and between designs. Any difference between the means must be tested to see whether it is greater than the variation between two different users. To determine whether there is a significant difference between means of independent samples of users, we use the two sample t-test. Any difference between the any difference between the means must be to see whether it is greater than the variation between the different users. To determine whether there is significant difference between means of independent samples of users, we use the two sample t-test. T equal to x1 minus x2 mean of the samples equal to s1 square divided by n1 plus s2 square divided by n2 root. It means what we are doing? Mean first one, second one sample to be first minus. Then S1, S2. Here already we have seen, no? S1, S2 standard deviations. X1, X2 means from sample 1 and sample 2. N1 N2 sample size. Here also same. This is sample size. Mean S1, S2 what? Again standard deviation. Sorry. Standard deviation. Standard deviation. This one mean sample size. Sample size. So each is standard deviation divided by sample size for sample 1, sample 2, but that standard deviation to be square for a less value, no, very small value. That's why to be maximized. Then sample size divided, then same. That's one is to both. Then take root square. Then only that can be able to reduce scaling. Then x1 minus x2. After this result divided by what we find, this one. Standard deviation divided by sample size. The degrees of freedom for one sample t-test is in order. The degrees of freedom, one sample test is n minus 1. N minus 1 is the degrees of freedom for one sample t-test. One sample t-test is for n minus 1. This total up to n, we are deducting only 1. It means what we deduct we take here. That's also 1. For two sample t-test, simple formula is n1 plus n2 minus n2 for two sample. For two sample t-test, sample formula is n1 plus n2 minus 2. However, the correct formula is given by Welch-Satterthwaite procedure. The correct formula is given by Welch-Satterthwaite procedure. It provides accurate results even if the variations are unequal. So this is the formula for this. Okay.